Problem 2.3. Estimate the energy input required to solder together two very long pieces of bare copper wires 0.1625 centimeter in diameter with a copper solder that melts at 195 degrees Celsius. The wires are positioned vertically in air at 24 degrees Celsius and the heat transfer coefficient on the wire surface is 17 watt per meter square degree Celsius. For the wire alloy, take the thermal conductivity 335 watt per meter degree Celsius. So in order to solve this numerical, let us draw first the schematic of this problem. So as you can see here, there are two very long pieces of copper wires and they are supposed to be soldered at this point, soldered together. Those wires are of same length and same diameter and made up of copper having same thermal conductivity. Those wires are exposed to the air having temperature T infinity and convective heat transfer coefficient. We are supposed to calculate the energy required to solder these two copper bare wires. Here, as it is mentioned, the wires are very long, so we can assume them as wires of infinite length. Now, if we closely observe the joining of these two wires with the help of solder is nothing but two fins of infinite length are connected to the heat source. So this will be the heat source point. And let's say this solder is at temperature Ts. So we are supposed to calculate what will be the energy required to solder these two wires. Now if we can closely observe, if we treat these two wires as fins of infinite length, whatever heat it will be supplied to melt the solder to join these two copper wires, the same heat will be conducted through these two copper wires under steady state conditions. So if we could calculate how much heat will be transferred by these two wires, treating them as a fin of infinite length, that will be nothing but heat required to join these two copper wires. So let us solve this. In order to solve the problem, let us first enlist all the given parameters. So as we have given, the diameter of both these copper wires are given as 0.1625 centimeter, that is 0.1625 into 10 to power minus 2 meter. Solder that melts at 195 degrees Celsius, this is nothing but solder temperature, that is surface temperature at which roots of the fins are connected, that is copper wires, and they are exposed to the air at 24 degrees Celsius. So base surface temperature will be Ts 195 degrees Celsius and surrounding air temperature is 24 degrees Celsius. The convective heat transfer coefficient of surrounding air is 17 watt per meter square degree Celsius and thermal conductivity of the copper material is 335 watt per meter degree Celsius. Let us enlist the assumptions involved in the problem. So let us first assume one-dimensional steady state heat transfer from both the copper wires. If we assume steady state heat transfer from here, as you can see here, the heat required to melt the solder, the rate at which heat is required to melt this solder will be the rate of heat transfer from these two fins under steady state conditions. So if we could calculate the rate of heat transfer dissipated by these two fins, that will be the rate of heat required to melt the solder and to join the copper wires. Then assumption number 2 will be no thermal contact resistance at the solder surface. So because of this, temperature of the fins at the root, that is where they are connected to solders, will be equal to temperature of the solder. Then isotropic and homogeneous fin material, fin or copper wire material. Assumption number 4, no heat transfer due to radiation. Then assumption number 5, assuming copper wires as fins of infinite length, that is, their L tends to infinity. And finally, constant properties of surrounding fluid, and in our case it is air. What you are supposed to find out, we are supposed to find out heat transfer by fins, that is equal to heat required to melt the solder and to join the copper wires. Now let us do the calculations. Now we know that for infinitely long fins, rate of heat transfer is given by K into AC into M into Ts minus T infinity. If you don't remember this formula, you can find out from data book of heat transfer. You can refer data book, heat transfer data book by C.P. Kothandaraman. There you will find the heat transfer rate by fin of infinitely long length. So let us say this is equation number 1. Now in this equation, K is known to me, AC is known. AC is the cross-sectional area of the fin, M is the fin parameter. So let us calculate one by one. Since copper wire is of cylindrical shape, so its cross-sectional area will be pi by 4 d square. So it will be pi by 4 into 0.1625 into 10 to power minus 2 whole square, and cross-sectional area comes out 2.074 into 10 to power minus 6 meter square. Then perimeter of the fin, so perimeter of cylindrical shape is pi d, pi into 0.1625 into 10 to power minus 2, it comes out 0.0051 meter. Next thing to be calculated is fin parameter given by HP over K into AC, square root of this. Value of H is 17, value of P just now we could calculate 0.0051. Thermal conductivity is 335 and area of cross section, please do not get confused. This is suffix. So 2.074 into 10 to power minus 6 square root of this entire term. So calculation of this term will give me value of M as 11.17 per meter. Therefore, now we can easily calculate from equation 1, rate of heat transfer by fin will be equal to, the value of K is 335 into 2.073 10 to power minus 6 meter square. M value is 11.17. The value of Ts, that is solder surface temperature, is 195 and T infinity is 24. So Q fin is nothing but 1.326 watt. Now this is the rate of heat dissipation or fin, rate of heat dissipation or heat transfer from copper wire as a fin, from single copper wire. There are two copper wires, so they will be able to dissipate the heat twice of this rate, and that heat is nothing but heat required to melt the solder wire and join the copper wire. So therefore, heat required to melt solder and join copper wires is nothing but twice of this heat dissipated by one fin. So Q will be twice into 1.326. So Q comes out 2.652 watt. So this will be the rate of heat required to melt the solder and to join copper wires. So this way we can solve this numerical.